Okay. My name is Eskil Steenberg. I'm having some feedback right now. Yeah. We're here for feedback. Again. So, I'm heading the Burst project, and I guess most of you have been here before and met me, and I was here both last year and the year before that. So, my first initial question is, how many people have heard me speak before? You. Right. Let's talk a little bit about what Verse is. I'm not going to spend too much time on it because it's like the third year I'm here. I know some of you have heard it, some of you are already developing for Verse, so I'm not going to spend too much time on that. Then we're going to talk about what's new, and then we're going to have Emil and then maybe some other people show some stuff that is going to be Verse. I'm going to show some stuff as well. So, Verse is a network protocol for computer graphics, mainly 3D graphics. And what it means is that you can have multiple 3D applications talking to each other and sharing data in real time. So if you have two applications that do modeling, they can see the same model at the same time, and when you pull a vertex in one of them, the vertex moves to the other one. So you're completely collaborating. And Verse works with any number of applications, and it usually has a central server or a hub that you connect to, and all applications that connect to the same hub work with the same data. And there's a number of interesting features to this. One is that you can be many people working together. One is that you can have multiple applications working together. So you don't need to have one large application. You can have multiple smaller applications. And that means that you can switch applications whenever you want. If you don't like one part of your application, you can use another one. And it's like using one of the same application. When you change something here, it changes in the other application as well. So you don't have to sort of use one application, save it or export it, and then import it to the next. Everything just flows as if it were different windows on the same application. And this is pretty powerful when it comes to how you develop your applications. You get a lot of freedom because it don't matter if you screw some part of your application up or if you make a bad application because someone else can make an application that's good. So you can specialize a lot. And that makes Verse very, very interesting. I spoke to Tom like 4 years ago for the first time. And back then, none of them was still alive, or barely still alive. And we spoke about getting Verse into Blender, so the Blender users could talk about the Blender users and use this to collaborate. And he was very interested in this, but at the time, they had financial difficulties, they had lots of issues, they had deadlines, so they said, we love the thing, but not right now. And then what happened was that a few months later, non-member didn't exist anymore. And then, two years back, I met Tom finally, face-to-face, because I called him, talked on the phone. I got his name from a guy on the street. He basically said, the street should really use this in 3D Studio Max, but everyone who works at the street are assholes, basically. So, and they will never get it. But you should talk to this guy Tom, because he's really great. So he was really sort of referring to a competition, talk to him. So finally I met him at SIGGRAPH. I showed him some stuff. I showed him my modeling tool called Roll, which I'll show briefly here today. And he said, wow, this is really cool. We're doing this Blender Foundation thing, and he told me, all that he just told you about Blender Foundation and what it's going to be. At that time, Blender was not open source yet, but the foundation had just started getting money, and found that they got a lot more money than they thought it would get a lot quicker. So he was still saying, this might actually be something. This might not just be a stupid idea, this might actually try to work out. So he asked me to sort of start thinking about what would Blender do technically in the future? How could we sort of move on? Because Blender as a source is pretty old, and sometime in the future we want to move on. And we also want to move in a different direction from what all the other applications are doing. We want to use hardware acceleration, we want to use OpenGL2, we want to do networking, and we want to make an application that is made by and for people who are in a community, not just big Hollywood studios. So we want to do something different. And back then I started developing an idea for a project that the Blender could do. That was back then known as the Next Generation Blender Project. And way later it became the Purple Project, which is now headed by Emil, who will talk and show some things he's done with that. So the next thing we did was that a number of people came together to ask the European Union to get us lots of funding for a project called Universe, which is sort of an umbrella project that does all kinds of applications that has to do with verse in different ways. We have some, and Blender is a member of that. And Blender is sort of the channel for all that other application, all the things that we've done in this to get it out. So Blender community is sort of our way of spreading what we're doing. And we're also seeing that we're using Blender CDS, we're using web pages on Blender, and so on. So Blender has really become like our home for this project when it comes to people finding us and getting part of what we're doing. And this project started in February. Last year when I was here, I knew that we had gotten the money, but due to regulation from the European Union, I couldn't tell you guys we got the money. I actually knew back then. In February we actually started this project, and then I and a few other people started working full-time on the verse, paid. I worked full-time before, but I wasn't paid. And we now have a number of partners that work together on this. I don't know if I should do a quick presentation of who you guys are. We have the Interactive Institute, as Thomas talked about this, which are doing sound things and also things relating to game engines and things like that. We have Helsinki University, which will also deal a lot with sound and acoustics and that kind of things for simulation. We have Fraunhofer in Germany that will work with rendering, and we'll see some rendering client for handheld machines using OpenGL, which I think is really cool. So you can actually do something in an application and look at it and review the work on a handheld wirelessly. So when somebody models, you can sort of see what they're doing on your little PDA, which is obviously pretty cool. The Blender Foundation obviously is a member of this, and there's a couple of content companies as well. There is a content developer agency called Arebus from Sweden, and there is from Hungary, right? Minus Plus, which is architect bureau that does, I don't know what they do, weird stuff. So all these people are now bringing together and starting working on different aspects. And my work, I work at KTH, which is the Royal Institute of Technology, at the PDC, which is the Center for Parallel Computing. So we're like the supercomputing people at KTH, and I have nothing to do with supercomputers, but it sounds really cool. I don't get in touch with supercomputers, but still. What we're mainly working on is tools, and tools for artists and tools for people who want to use the system. So that's what really we've been working on. And for the last year, unfortunately, I've been very busy with lots of things like rewriting code that is, for opening windows and doing boring stuff, drawing fonts. Everybody hated my last font. For some reason, everybody hates my new font as well, so I think it's a lot better. I don't see how you can do it much better, but okay, hate it. And stuff like that. So we haven't seen many new cool applications from these, which is sad. But now we're at the point where that part of the code is really up and running. And that's really interesting because now, when we have a lot of foundation code, we can write applications really quickly. Another thing that is updated a lot is Verse itself, the network protocol. The Verse networking protocol is a couple of different things. It's the actual protocol, which is how you pack the bits and send them over the network. And that's a little bit more complicated than it sounds because you have to keep track of lost packets. Because we use UDP, which is a very fast way of sending data, but it also means that data can get lost, it can wind up in the wrong order, and so on and so forth. So you really have to think about how you do things. And that makes that part a lot more complex, but it makes it a lot better when it works. So I've done some pretty extensive rewrites when it comes to those parts of Verse. And other parts of Verse is the actual API. So if you want to program Verse and use Verse, there's an API that you use with an HFOB, and it's pretty simple to use. And we've been working on fine-tuning all of that. And then on top of this, there is the whole thing of what do you send over the network? Well, there's a format. How you describe graphics, how do you describe a vertex, how do you describe a polygon, things like that. And we're also working on fixing all the quirks on how to describe anything we want to do. So the latest release that we're going to release here at the Weather Conference is release 4. And we have a release number system now that when we say that we're release 4, and then we won't make any changes to the API until release 5, and we'll announce it with release 5. Back in the days, we used to sort of release new changes all the time, so everybody had different versions. It was really difficult to develop for Verse because everything kept changing all the time. Now we sort of say, okay, here's what we're going to do. We tell everybody on the mailing list, and we let people take the time to sort of review and figure out, and people can talk about it. And then we'll release, as before, we'll release pre-versions where we show this is what it's going to look like, this is what we're working on, try to stamp out most, all the worst bugs, and then we'll make a release. Once we've done a release, we'll do fixes. So that won't change anything with the API or the compatibility between different applications. It'll fix bugs. So I wrote out a note just to not forget. It's gone. Here we go. Yes? Just a few of the changes that have come in the latest version. We now have functional curve support, so we can do motion curves for animation, basically. It's a pretty simple, pretty powerful system of animating things. You can animate materials, you can animate blend shapes, and you can do bone animation. Well, that's another thing we've added for these 4 functioning bones. And there's now 2 different ways of doing bone skinning. So it depends on how you want to store the data. And you can store it in different ways now. That makes it a little bit more flexible and a little bit more, less memory consumption. There's a lot of small changes, like we changed sizes of names, we changed names of functions, and small tweaks really, stamping out small differences. The material node, which handles all the material in Verse, now supports volume shaders, which means that you can do subsurface scattering and that kind of rendering in Verse. We now have timing, so the Verse can time things. So if you make motions or animations, you can synchronize things. We have encryption, which isn't really finished in version 4. We wanted it in version 4 but it's going to be too much work, so we're not going to see it just but it's coming pretty soon. And the encryption we have is a very, very strong login encryption that makes sure that when you connect to somebody, you send your name and password really securely so no one can sit in between and listen or take your package all the way and get your name and password. It also means that when you connect to somebody, you'll get a receipt that says, this is my identity, this is me. And the next time you connect to that client, you can compare that receipt and see that it's the same receipt. And you don't just do a compare. This receipt is actually a public key in an encryption system so that you can check that nobody else can give you this key, because they also have to encrypt something with a hidden key that only that host that you're connecting to has. So you can really make sure that the person I connected to before is the same person. And this receipt doesn't have to travel through verse. So if you have a super, super secure server, you can have people with briefcases with keys in going to your home saying, here's the key. So the key has never traveled over the internet and you've never received it. And by doing that, you have really, really secure logins. Once you've done the login, you can't really have that kind of encryption for the data, because the data is performance bound, right? If you do whole lot services, if you paint, if you do stuff like that, you really want to have lots of performance. And having that kind of strong encryption really kills your performance. So what we've done is we have a really simple algorithm, which is XOR, which is just trashing all the data. But you have a key that is very, very long. And that makes this very, very simple algorithm extremely safe. In fact, that's what military encryption usually uses. They just have very, very long keys. So that means you have to transfer this key, and that's usually a problem people say because the keys are so large. But large in this world is like 2,000 bits or something like that. And that's not very large. Sending 256 bytes of data is pretty easily done. So we said it's better to send that data once and then have really fast encryption that takes no time to decrypt and encrypt and then get really good performance. So that means that we have really secure login and really secure transfer. The transfer is really easy, so it's already in there. And the login is almost in there, but not finished. So the login is not encrypted yet, but that's coming. So that will probably be in release 6. Then we have audio. Audio has been added, so you can store audio and you can stream audio using this. And since we have a lot of audio people, we're going to see some cool stuff coming out of that. Hasn't been a lot of testing, hasn't been a lot of work on it, but the API is there and you can start using it. Anything else new? Yeah, the final thing we're going to fix, which isn't in CDFs today, but is going to be sometime during this weekend, it's on my laptop, is all the bitmaps in verse are sent in tiles. The tiles are 4x4 large. We're going to change that to 8x8. It's a silly change, but it kills a lot of overhead, so the performance is going to be better for large bitmaps. I guess that's that. The new stuff in verse. So a little bit about how do you get about this. Well, if you want to start look at verse, the first thing you should do is go to our webpage, which is looks like this. It's at blender.org/modules/verse, or if you just go to the Blender site, I hope you'll recognize this. You see a verse link right there on the side. So just click on that and you get to the site. We're going to work on the site more and update it. The best thing to do once you've gotten to the site is there's a spec for verse, which unfortunately hasn't been updated for release 4 yet. So there are some changes. But that we're going to start working on that now that release 4 is out. We've really decided what the changes are. can start reading there. And then join the mailing list. The mailing list has grown considerably the last year. I think we're about 80 people on it, and it's quite active. People are asking questions. There's about 400 messages in the archive. And reading that will give you lots of hints and things on problems. But please, if you have questions, just ask us, and we'll help you as much as we can. As I said, both I and Emil used to work at writing the first version of verse, so he knows a lot about verse. So both he and I and Brink there, he knows a lot. He's a great guy who's got some great stuff with verse. So we love to answer your questions. So just come along. So okay, so let's show some applications. Let's start by showing verse, which is probably not the greatest application to show, because this is verse. It's simply command line server running, just outputting some, I guess, things we should remove, things that shouldn't output. But it usually has this line, and that's about it. So you run that on your computer, and then you can start connecting the tools. I'm going to show a bunch of tools that I'm working on, and I'm going to start with connector, because it gives a good image of what verse is. Connector is not really a tool in the sense that it's a tool for being an artist. It's more a tool for handling verse, for figuring out what's going on a verse server and changing data. So I just ported everything to the Mac, just on the flight over. So things are not as stable as I would like them to be. So I'm going to have to excuse if there's bugs. Well, the first new thing you see is this intro, but sometimes, for some reason, it stops when I don't update. So let's connect to the server. We have a new login window here with name and password. Very nice. Let's see if these work. Takes an age to get. I don't know. There we go. I have no idea why it is. So this application allows you to see all the data that is in the verse, and it's in the form of nodes. Nodes are drawn as planets in this application, and you have your nodes, and you can move them around and look at them, and then click on the background, you get this list of all the nodes that are available. And then I click on this one, and then now I can see these two nodes, and I can play with that. But this is really the repository of all the nodes that is on the server. And you can click on this one, which is new, to create a new one. And here we are. So once you click on your node and have your node, you can click on it to edit them. And then you can see the content of them. So let's start by looking at the object node here. Object node is the core of the node where all the that's the node that says, here's an object, and it links to geometry and to materials and all the other things that we need in order to get an object in the world. So it has stuff like, you can click on these little things to expand. It has position, so you can change the position of the object, rotation, the scale of the object. It has light sources, which is, you can make this into a red light source by doing this. Red light source. So object and light sources are basically the same thing. You just pull the lever and you have light source. You have links to other node, which is down here. I haven't linked anything yet. And you have tags. Tags is something that all node types have. And they are in groups, so let's see if you can break one. So here's a group. And now we create a group. It's called group 0. Change it, I guess. Now we change it. And then we can create tags. There's a tag, and it's a type bowling. And what tags are is basically your own you can add your own data to nodes, which you can get to decide. So if you're making a game using verse, you might want your object to have a tag that says, this is a player. And then all the applications that connect to verse can know, oh, this is a player, this is a character running around. And you can write an application that connects to verse that sort of sees that, oh, this is the player, I handle his motions as walking and whatever. And then you add a tag that says health. And you can say, okay, this is the health of the player, so you can say if health is the same as 0, I don't allow this character to walk around because he's dead. And if he's 100, I'll let him walk around. So this, for instance, is a Boolean, and I can change it to cool. Now the Boolean is cool, and we check says, yes, it's cool. And you can click on the type of Boolean and choose some other types, like for instance, integer value. It has a number of different, you can choose text, you can choose reals, you can have links, you can have blobs, which is any type of data, you can have vectors, and so on. So, that's the tag. I don't really know if the method works. Methods is a way of creating functions that the object has. So if you're making an application that can do something really cool, say you're making an application that makes balls jump. It connects to a server and makes objects go up and down, right? Then you can have a function on the object, a method call, that says height. And then you can send signals that says how high this object should jump. So maybe it's setting still, and then you can click on an interface or something and send a signal to this other application saying, run this thing called jump, and set it to 2 meters, and then it jumps 2 meters. So that's the way that different applications can communicate with each other. And I have no idea if this works. Here's a group, because they're all grouped, and we can create a method. There's a method. And add a parameter to the method, like this. Now it takes an integer, and I can name the integer, and, well, you can add stacks of all the parameters. It's very C-like. So, there we go. I guess this is the boring node. It doesn't do much. But let's look at the geometry node. This is one I created earlier. So there is already geometry in this server, and unfortunately, this machine isn't really cool because it doesn't support OpenGL 2.0. What I've started doing in the last couple of weeks is create a new library called Persuade that will do all the rendering that is needed for my applications. And in this case, you will actually see the geometry in this ball. So you will see which geometry is which. That rendering is counted out right now because it needs OpenGL 2.0. It's going to work on OpenGL 1.x in the future, but I haven't had the time to do that, so I'm sorry, but it's coming. So right now it's not, you can't see it. So data in the geometry is in layer form, and that means you can have multiple sets of data that correspond to vertices or polygons. So first we have an XYZ layer. That means that we need one XYZ position for each vertex, right? And that's always there. And then we have three or four values for each polygon in this layer. And that's basically saying, here's how you connect the vertices into a polygon, right? So that's how that data is stored. But then we have some other ones that are not needed, but you can see that they can be deleted, so you don't need to have them. But one is select, which is one vertex, one floating point value for each vertex, which says if it's selected or not. So that means if you have two applications that needs select, they can work together. So you can use one to select something, and you see that selection coming up in the other application, which is really useful in some cases. I have an application later on that actually supports that. I don't think I'm going to show it because you have to run two applications next to each other with these tiny screens. It's not very fast, but it works. So it's pretty cool. We have creases, which is edge creases, because all the polygons in Verse is actually subdivision surfaces. So it should be rendered as superposition surfaces. And then you want to create some information where you say this is a sharp edge and this is a soft edge. So that's data for that. And then we have two more layers. One that says one floating point value for each corner of a polygon. That is a U value in texture mapping. And the other one is a layer that says a V value for texture mapping. So that's a two-dimensional X, Y space of where you put the texture mapping. Sure. It's because you can have something 50% selected. So it's called soft selection. I think 3D Studio Max has soft selection. I don't know if any other application has it. But it's a pretty useful thing because you can do things like select a part of an application of an object and then say, okay, I want this to be fully selected, but I want everything around it to be like smoothly selected. So when I move it, I don't get this part going out. I get this smooth sort of bell curve movement, which is pretty nice. So here we also have support for bones. I'm not sure in this application I've written all the support for it, so I'm not going to show it. Then we have a material node, which is probably the coolest part of this application. My mind. Which is right here. And the material in this universe is based on nodes. Smaller nodes inside the node. And since there already are nodes, we call them fragments. And this is a fragment. So, come on. There we go. Here's a fragment that says color, right? So, we do color. And it has rendering too. So it renders. Very nice. And to make a graph, which is really what you want to do, you have to have an output. And this is an output. Right now, nothing is connected to the output, so it becomes black, which is, in this application, the standard color. So we're going to make a very, very simple material here just to show how it works. Here is a blender. No, so we connect the output to a blender that blends the color and light. Like that. And then we can see the shader is showing up. So this is a very simple purple material, right? And what you can see is that it's a material that takes into account the incoming light and multiplies it with the color. And that's a very, very simple material. But there are some really more advanced stuff you can do. You can do, for instance, you can add a reflection. This is a reflection. Now I'm going to remove this one and here instead. And then we have a reflection. So now we have an object that reflects purpley. So, as you can see here, I only have a couple of fragments, but you can have a lot of fragments. For instance, you have colors, light, reflection, which I've shown. There's also transparency. There's a new one, which is volume for subsurface scattering, like translucent skin type of materials. You have geometry, where you can bring in information from the geometry layers that I showed you earlier. So this is how you get in UV data or per vertex coloring and stuff like that. There's texturing, textures. There's noise, which is your average Berlin noise. There is blender, which is over here. And you can blend things in multiple ways. You can add, subtract, you can multiply, divide, and a few others. You have a matrix, which is your average mathematical matrix. So you can switch colors, swizzle colors if you want material that when you light it with green color, it shows up red or stuff like that. So you're using weird stuff. And we have animation to really animation curves, so you can do an material with a texture that scrolls or scales or it doesn't or changes color, according to time. We have alternative, which is that sometimes you want to make really complex material, and then you might say, but there's another way of doing material. So you can do materials in two ways. You have a split where you say, here, from this point, you can either go in this direction or in that direction when you parse this material, which can be useful for some rendering routines. I'm going to show one more. So, one thing you can, for instance, do with this one is you can make it boring. So this is now becomes like a foggy reflection. Let's bring in this one. This is so crazy. Now we have a really starting to get like a psychedelic type of material. So what this is simply a ramp going from red to green to blue, and it takes in the blue color from this image and makes a lookup. It sees what number it has and looks onto this ramp and takes that color and puts it instead. So where it is really dark, it goes reddish, and where it's really bright, it gets blue. So I can click on the blue, and I can change the blue to purple. And it's really nasty materials for this thing. And you can click on these to select which one. You can click on them and grab them and move them. You can click on them in space to create new ones. And then connect it, and then change it to purple. And then once you realize that you've done something bad, you can click up here to destroy one of them. So it's a little bit of a nice interface there. So, and then if we click on this sphere, we can go back into this world where we used to be. So now you can see the sphere when you play with it. We have bitmaps. Should I see? Whoa! Sorry, I started with a game. I built it a little game. This is me having too much fun. Come on. Die. Okay, you can try. I'm going to die and I'm going to make it because then I get to see the nice game over sign that I did. A couple more lives. Asteroids. Funny thing about this game is that the size of the asteroids and the number is the amount of. I can't die in this game. There we go. The size of the asteroids are the size of the nodes. So what you can do is you can. If you click on the background of the drag, you simply scroll. If you click on the background of the edge, you can zoom. So you can make them really large, which makes the game quite different. Let's see if we can see. There's little spaceships going around here sometimes, and the game starts when you click on them. It's really hard to see, so that's why I have to click on them. I'm going to make them brighter and more visible, so that you don't start the game by accident. Come on! Here we go. It's like a moonland now. There we go. Oh. I have too many stars. Oh, okay. Quickly and painless. So, that's just me. So, actually, the game turns out it's pretty much simpler when they're really large. Even if they are really easy to crash into, they're so easy to hit that they disappear pretty quickly. That's a tip. And you can bring out lots of them, which is really hard. So this node is the texture node. And you're basically going to set a number of a size because it's a three-dimensional texture, and you can then create layers. For instance, you can have RGB, useful layers. You can have layers that are in different sizes: 1 bit per pixel, 8 bit per pixel, 32-bit, 16-bit, and 32-bit floating point, and 64-bit floating point, which is a little bit of overkill, but you can do it. There's also the text node. The text node is not supported in this application. I'm sorry, but this application is always lagging behind a little bit of all the functionality. Since we add functionality to Verse, this application is really where you can test out the functionality and see what's going on. You can really go in and check on the data. This object have a tag or not and stuff like that. So I'm trying to keep up, but I haven't been able to. So the text node has not been implemented yet. Emil has worked a lot with the text node, so we sort of know that it works. And usually I try to implement things just to test them here, because Emil really needed it for the Purple project. He did it for himself, and that sort of saved me some time. I could wait to do it. So let's look at a completely new node, which didn't work before, and now we're here, which is the curve node. The curve node is very interesting because it has curves. Each curve can be 1, 2, 3, or 4 dimensions. So I'm going to create a 4-dimensional curve here. Click. Now we're going to 4-dimensional curve. And down here, this area here is the editor. So I can click there, get a point, get another one, get another one, get another one. So here we have a curve. Very nice. And if we click on one of the points, we have to move it up and down and sideways. And this is really a keyframe in time. I'm moving in time, and I can click on it multiple times to get all the dimensions. Now I have all 4 dimensions in this. So here is a nice set of curves. Hold on. Okay, and they have handles. You can see the handles here. You can grab one of these handles to sort of move it up and down to get a tap handle. So, for instance, if you want to do a bounce here, right? And I'll move this one like this. So this might be like a ball bouncing down and then bouncing down here, and then maybe it's rolling down something or whatever. So by doing these handles, you can really design your animation curve. This is pretty standard stuff that most animation tools has. So Verse supports that. And then you can click on the background and pull to scroll if you have it really long, or zoom if you have really wide stuff. I think I turned it inside out. There we go. So, well, it's a pretty useful tool. And it's also very useful for people who want to program and test everything. You can really play with it. Another thing is that this span ring is scalable. So if I grab this point and I move it upwards, everything scales down. Now it's very high, right? And everything is always visible. There's some fit and finish to this application. And if I close this one, it becomes larger, so you get more space. And I can open it and also turn this away. And you want to see it. So, if you have multiple, let's create a 1-dimensional curve. I can click here to say, okay, now I want to edit this one instead. So now I have a 1-dimensional curve. So that's a curve editor. It's pretty simple, pretty nice. So I think that concludes my demonstration of this application. So let's go on to some fun applications. I'm going to have to warn you guys that this is a Mac, and apparently people at Apple are not too fond of multiple mouse buttons. So they do support it, but not so well. So, see if you can get my modeling tool. Everyone has been here before, has seen it a million times, so I'm going to do a quick one. I hope. It might crash. Let's see. I don't know what's going to forever connect. So this is my modeling tool. This modeling tool requires you to press multiple mouse buttons at the same time. And there's a bug in Glut that makes once you press one mouse button and then press another one, if you release the first one, you never get a release call from the API in Glut. And that's a bug in the Apple implementation. And I talked to the guy who wrote Glut, and he said it's not my fault. And then I talked to Apple, and they found the bug and have fixed it, but it's not out yet. So maybe in Tidal, this application will work properly, but right now it's not really working. So right mouse button in this application simply rotates my geometry, and if I now press the left and middle mouse button, I can zoom and pan. So let's just look at this object and draw some. You click on empty space or existing point and just draw lines. Like this. And you can see there's these blue lines here, which are XYZ lines. So I can snap to those. Like this. And then when I go over a point, you can see this thing appearing, this logo type thing. And that tells me that if I click now, I'm going to hit it, right? So I'm going to hit that one right there. So now I'm connected these two, and then I get a surface. So what you do in this application is really you draw the outline of your geometry that you want, and you get it. Okay, so here we have some geometry. Cool. If you want to delete something, if you want to split something, let's start by splitting something. You just click on an edge and start splitting like this. And if you want to delete something, you click in empty space and you draw a line. And when you cross an edge like this, you see there's a red sort of outline on the line. That says that right now if you release, it's going to delete. Like that. So that's how you delete things. You sort of cut away the stuff you don't want. So let's say I want to change this with a select. Then I simply draw click on nothing, and then draw outside and do a circle around it in a lasso, and that's the select. And then this manipulator thing comes up, which makes so you can move it out. And I'm going to click on it to zoom in on the things I'm working on. So now I can grab one of these lines, which are X, Y, Z, right? I can click on the middle to snap it to a specific point, like that one. I can click on these arcs, you see, to rotate. And I'll rotate my selection right around it. And rotate this way too. And I can press outside of this to scale it. And when I scale it, I can go to these blue lines to scaling this one dimension. So you don't have to switch modes in this application. And that's a really interesting feature. You never have to say, okay, now I'm going to go into select mode. Now I'm going to start deleting. Now I'm going to bring out the tool to draw. You do everything at the same time just by doing it. So just start, if you want to select, you select. Right, you have a selection. If you want to delete, you delete. That's it. And if you want to draw, you just draw. Right? So that's really a very nice way of working. You never have to sort of think ahead of what you're going to do. The idea with this tool was to have as few sort of tools as possible and have just drawing. And that's why this draw function is so important. You can draw anything just by drawing it. If you have an idea in your mind of what something's going to look like, you don't have to think, okay, so I want it to look like that. What tools am I going to use to get there? You just draw it. just draw the outlines, the cage of the model that you want, and you get it. So I think it's this application has so many features that are so hidden that it takes forever to show them all. But let's see if I can do this. Wow. Now we can extrude by pressing the middle mouse button. So now that I release, nothing happened because it's happening. So let's extrude. Small things like if you click on the right button, it zooms in and turns to the face. If you want to select a surface, you can also, instead of drawing a surface, click on it. Now it's selected, so you can include that surface, that surface, that surface. We only have one way of doing selection, which is vertex selection. There is no polygon selection, there is no edge selection. Whenever the application needs polygon selection or edge selection, the rule is that any edge where both vertices in the edge are selected is a selected edge. Every polygon where all the vertices in the polygon is selected is a selected polygon. This turns out to be some issues sometimes. For instance, if I select that polygon, and I want to select this polygon, whoops, the middle one got selected, right? Because if all the vertices in that one is selected, and all the vertices in that one is selected, that means all the vertices in this one is selected. So you can't really do that. So that might be a problem, but it turns out that almost never happens that you get that problem. If you want to do something for that vertex and that one and that one, you can do it twice, right? There's one polygon, for a new selection, do it for the other one. Okay, it's a little bit more work. But it turns out that it almost never happens. And in normal application, you spend so much time doing switching between different modes that it turns out to be a smart thing. On top of this, we're not going to spend too much time. We have pop-up menus, which is a middle mouse button. So if you press the middle mouse button in empty space, you see you get undo and redo, which is pretty useful. And there are multiple, so you can do multiple redos. You can also create new geometry. Now creating a new geometry node. Let's select it. Wait, there we go. Now you can draw a new geometry. Whoops, not a new. So you can use it. And I'm going to split it. And while I'm splitting, I'm pressing the right mouse button to make more splits. No, this is not going to work since it happens. Okay. So let's make a grid. This is very important because I'm now going to do something I'm going to show you in the next one. Okay, so here's an object. I'm going to click on that vertex and that vertex just to split these up to triangles. The verse handles both triangles and polygons, or quads. And usually you want to use as much quads as possible, because quads are usually, they take up less space. One triangle takes up the same space as one quad in memory. So having two triangles instead of one quad is bad. And when you're dealing with subdivision surfaces, if you're dealing with triangles, they rarely get as smooth as you want to do them. You can't do a cylinder with triangles. You can do it with quads. So I really suggest people use as much quads as possible. So now I'm going to click on that one, select it, and I can do it. Now we have a simple object. So other things you can do now, just to play a bit, is to say, click on this polygon, fail selection, and now we can click on different parts with the middle mouse button, which is the pop-up mouse button, to see what's going on. We can get some pop-up menus. We showed you that one, but there are other ones. If you click on this one, which is the manipulator, you got a whole bunch of stuff we can do. Like for instance, we can do this unselect. We can do duplicate if we want to copy things. We detach if we want to detach that part. Mirror it. We can do smooth selection, which I talked about earlier. So now all the vertices next to it got smoothly selected. You can start moving and see what smooth selection is good for. Undo for that one. And you can do flip to turn it inside out, and a couple other things. So you get a whole bunch of tools that are sort of hidden. And let's select that, and then click on this one on the surface, and you get different pop-up menus. So for instance, here I got one that says mirror, which means basically take the selection and mirror it depending on this surface that I'm using now. So this is the sort of mirror surface. Another one is flatten, which is my favorite tool in the whole world. Flatten and it becomes flat, right? So everything goes flat to that surface. And flatten here is really, really nice because what you can do with flatten is that if you're doing a very weird surface that comes here and you flatten a surface here, you get an edge here, right? And this edge is like all wobbly, so you flatten like this. And then you flatten this surface, right? So all the points here are going to move again. But that means that the first flatten is not going to be flat anymore, right? So then you flatten this one. And then you flatten that one again, and you go back and forth forever until they're getting flattened, 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 but never really flat. So therefore, what this flatten tool does is that it looks at the surrounding surfaces and says, okay, let's preserve their flatness. So that's why you can do multiple flats next to each other, and they don't screw up. It took a long time to code that, and I'm sure nobody notices it, but I love it. I'm an old modeler. Okay, so this tool, as I said, has so many, many features that I can go on forever, and I know that I've shown most of the features to most of the people who have been here before. So let's move on to the new stuff.
Just one question. How do you give an increase? Can you see the final?
Yeah. You can't see the final subdivision in this version right here because the rendering code is currently under construction. And that's what I said, it only supports OpenGL 2.0. I have a version working at home, and I have a graphics card with me. I have a GeForce FX. So if anybody has a machine with either ATI 9600 or better, or have a better card like this or better, or have a machine where I can put this in, tomorrow we're going to have another verse session in there where we are going to be more like loosely, and you can come talk to us, and other people who work in verse are going to show their stuff. So if you want to come talk to us, or if you have a machine, we'll see if we can get one, and I might be able to show you some OpenGL stuff. The OpenGL stuff is really cool, so I'm really hoping I can show that. Sorry, not this show, but too early in the morning to get it set up. So yes, you're going to be able to see the smooth surface underneath. And if you want to do creases here, what you simply do is you draw on a line, like this line, just click on this point and draw the line that is already drawn. And that's like filling in the line and making it sharp. So then you get a crease. There's another way of doing creases simply by selecting something, and then you're going to pop up menu and you can find a set crease. So that means you can make a whole model crease without filling in all the lines, which might be a bit tedious. So, okay, this is it. I'm going to go over to my next application. And I'm going to keep on being amazed that nothing has crashed yet. Here's my UV editor. It's always good to show the development environment. Okay. Way! We got our first crash. Welcome. Let's try it. There is some weird crash that I'm pretty sure that I fixed before, and it seems like I'm back, but I don't know. I'm going to be persistent. Oh, there we go. So, here's my UV editor. And you can switch your object here. Here's that object that we worked on before. You can see this flashing thing here. That tells you that there's no UV data in this object, so I can't edit it, right? So let's click there to edit, like that. This application supports the selection of locale, the earlier selection. So if I select something in locale, that part will be as usual, whereas everything else will dig. So that means that if you have a really complex model, you can use the 3D to select an area. This is the thing I want to work with in my UV editor, and then only that part will be editable in this version, in this application. So simple things you can do is just your projection, X, Y, Z, like this. Right? Very, very standard stuff. We have the same type of selection when we have lasso selection. You can see the edges here. You can select one of the edges by clicking on the corner like that. Right? Because you want to split parts and stuff like that. So the point that actually selects when you do a lasso is not the corner, it's this corner. So that means that I can select polygons like this and really select, whoops, like that. Now I selected those. So that makes it really easy to, when you're doing UV editing, to cut things apart and decide I'm going to select this. Usually, like in 3D Studio Max, you have UV maps going all together in one place, and they have to click on it and drag it out, and you drag out one of them, and then you drag out the next and the next, and in the end you get like a zillion points, and then you have to sort of sort them by hand by moving them all together, and then clicking, and it's a mess. So with this manipulator, you can move in X and Y. It looks like a clown. And by pressing here, you can move it around. You can rotate. You can scale. And you can scale in two different axes as well. So that's a simple thing to do. But you can also, let's just select a couple here. If you click on one edge, one pointer, you can see that I move those two. And they get snapped together. So actually, if I click on this one and this point is actually the same point as that one. When I start moving it, they all stick together. So it's very easy to stick things together. So when you pull them apart and want to pull them together, these 2 points should actually be in the same point. They will really easily snap. Those are pretty easy things for you'd think all applications should have them, but apparently, UV editing basically sucks in those applications, in my opinion. So let's take a look at these details. For instance, you can click on an edge to select the edge, right? But you can also do this. Select this edge, move that away, and then grab this edge, and then snap it. So I can snap it to another edge. So if I want one edge to be adjacent to another edge and be perfect, I can simply drag it around here. And I can move it on this side. Now it selects this polygon, right? And now it selects that polygon, so it gets twisted because it's on the back further part. So that's why it sometimes twists. That depends on which side you are. That might be a little confusing, but that's how it works. So let's go over to the price-winning feature of this application, which is clicking on a polygon and moving outside the polygon. And then you see what happened here. Well, the next polygon got folded out, right? If you think of this geometry that we had, so select everything, and then do this. If you think of this as a UV map, you say, okay, this is fine, right, to have my texture. But since this polygon in the middle is pulled out, all the polygons around it is going to get stretching, right? And that's really bad. So what we want to do is have these polygons be longer, right? So we can edit them to pull them out of it to get less stretching. But by doing that, we have to figure out how much to pull them out. And that's really difficult to do by eye. You can sort of pull and say, okay, this looks okay, but you don't really know. So that's why we have this feature where you simply go over the edge and they move out like this. So now I can unfold this by just going from edge to edge and pull it out like this. So let's keep on doing this. Like that, and is the fold out, right? This is the paper piece that you can print, and you can fold it together, and it becomes the object that we have. And there's no texture stretching whatsoever in this. And you see those little blob things that showed up here? What are those? Well, those are icons that show, here we found an edge, right? That is like a split edge that is connected to one end and not the other one. So by clicking on this, I simply close them. So now you're actually stretching these triangles. They don't get perfect the way they were before, but you use more of the texture surface, which is something you want to do sometimes. Think if you had a cube, you can sort of, or an extrude of a cube, right? And you pull them out, and you take out all the wings, right? And then you have a plus sign, and then you say, okay, I'm going to lose these, so let's stretch them out to the edge so that we get something looking like that. So I get a square instead. And then I get to use up all my texture space, more texture resolution. So that's what they're for. And then there's like tiny features. For instance, you can all see that this thing is not straight. So let's select it, click on an edge, and say straight selection. And it doesn't work. Well, there's a lot of features like square to make a polygon quad square. Strip, which doesn't really work yet. You can project polygons. So if you have a surface that is like, you have this surface on a face, you can click on this polygon and say, that polygon is normal, that direction is the one I'm going to project from, right? Instead of just pressing X, Y, Z, you can select a specific polygon. As it turns out, when I do this fold out, I sort of do that, right? I fold out every polygon so that it's projected from the correct angle for that polygon. And that has sort of thrown me off a little bit, because when I started doing this program, I thought to myself, oh, I'm going to do 1,000 features. And then I did the fold out feature, because that was the feature I wanted to do most. And then I realized that most of the feature wasn't needed, because the fold out feature was so nice to work with. You can play with it, like, here's something I like to do. Go on this edge, and that edge, and that edge, and that edge, and you can spin them around. It works in a manner like a fog, and its wheels start flying about. The open edge is pretty small here, so. Oh, you do that forever, really easy, clean it up pretty quickly, get back to where we were, like that. So, that's that application. Emil, you can start setting up now. So, you be after. Emil's going to start setting up, so I'll go. There's one fourth application that I'm not showing you that is actual rendering engine. Because rendering engine, as I said, is a library. And the library is just, it has like functions. It has one function called draw scene, that draws the scene, right? And what you want to have is an application that uses the function draw scene, and scenes where you can move around in the world and look at the objects and have them shine when you go to. And that application is called Turtle, and it's coming. It's going to be in CBS along with all the other code that we showed you today sometime during this conference. We're going to get to work on that. And this is really where I would like to sort of invite everybody to start working and playing with these applications. The application code for these is about 2.2 megabytes large, and I maintain all of it. And I'm trying, it's all portable, but it's not tested on all platforms. So please, I'm very interested in having other people come in and work on this. After this conference, I'm going home on Sunday, and on Tuesday, I'm going away for 3 weeks to Tokyo. So during that time, I have no control whatsoever of what you guys do, so you can really do whatever you want. So I'm really looking for people who are interested in extending these applications. And all the boring code is pretty much written. And there is everything for reading things and drawing things and doing all those things that you want to do. And the code is pretty clean. It's pretty nice. There's not much spaghetti code. So it's very easy to sort of come in, I think. There's way too little comments, but it's very readable code. I'm going to start getting, working on comments in code and getting into that. But I really would like to see this project, these applications, this group of applications, like becoming a set of new tools that is not just mine, but it's more a community thing. So that we can add new tools and spend more time in refining things. And,
Give me a hand here. Sure. Too many tables.
So all this code will be in CS. It's already been out before, but usually I think like putting out the zip file, and then there's a new zip file later, a month later. So it's been open source for very long, but it's been completely mine. I had control over everything. So come up and talk to me if you're interested in coding any of this. I think it's pretty easy to do. So it's all written in C. It uses OpenGL and Glut or SDL. You can compile them both. So please talk to me about this. I have a few other tools that I want to do. I want to do a paint tool, both a 3D painter for doing vertex painting and stuff like that, and another tool for doing ordinary like 2D application painting. And I have some really cool ideas for that. So if we start being more people, we can all start sharing the responsibility of keeping everything alive and things like that, and then we can sort of make more tools. The UV editor here that I showed you was written in about 2 or 3 weeks. And that's all the time it took to write it with all the stuff that is underneath. So it's really quick and really easy to write more applications. And now that all the underlying code is pretty mature and working, my hope is that we'll see we can extend this a lot the coming year. I'm going to be tied up in the rendering code for a while now, so it's not going to be a new tool, I would say, in this year, but sometime next year I hope to write some more tools. Another thing to say, some people might have seen my color corrector that I shared earlier here, called Nil 17. Nil is killed. The project is dead. I have decided that it's a really bad color corrector. It looks really cool and it's really fun, but looks pretty bad. So it worked pretty bad. But I've been contacted by a company who actually wants to work with me and make a new color corrector. And that's a company that works with high performance video. So it might resurrect in some form, but not among these tools. So, Emil?
Thank you.
There's one question.
Yeah?
Yes, I just love your UV editor. Is it possible to, or how hard is to integrate these editors with Blender perhaps? Is it possible?
We're hopefully going to see that later, but there is a project in the universe to make Blender plugin for Blender to Verse, so that all these tools can be used together with Verse and Blender. And I'm not sure when that will be done, but I hope we'll see something later today. There's also a plugin being made for Maya, so that you use Maya, and then you'll be able to use Maya and Blender together with all these tools. So we're getting a growing number of tools, and we're going to see some more stuff that's not done by me. So I'm going to take credit for that.
helping it. I saw the guy writing the Blender plugin looking like this when it's dimensional. Yeah, hopefully he'll show it tomorrow. But anyway, I'm Emil, and I'm working on something we call Purple. And it's something as simple as a data flow trigger plugin based application and using Perk. And now, of course, this is rather much to take in. And I'm going to have to cut this presentation very short because we ran late with the phone and everything. So I have maybe like 10 minutes. And there are 26 slides, so you do that. I think we'll actually skip a few of them. Anyway, Purple is trying to be an interesting way to implement the internals of a 3D package, such as Blender. And I'm not going to stand here telling you what's inside Blender, because frankly I don't know. I'm not an artist, as you will be painfully aware in a while. But you will be able to do things like tools and modifiers and constraint evaluation, enforcement, all those things you need to make 3D package stick. And you'll be able to do it in a very general way. And actually, making a 3D package is not a full goal, it's just a handy way to just use it for that. And Purple should let you focus on doing your data and free you from like I/O and storage things, because we use Verse for those. And it will keep the internals, the processing, very much separated from the interface. Actually, there's a network link there, so it's very much separated. And well, there are several points of doing this project. They're fairly obvious, you can actually gain something by using all the things that Verse gives you when you network in multi-user. And you should also build a nice development of it. It's plugin based, and you can write different plugins independently of each other, and then they should work together once you pop them into the actual Purple framework. There's some history. It seems like everyone's standing here is talking about the history of Verse and Blender, so I think I'll skip that one and go on with my plugin talk. So basically, the idea is that you can write something called plugin, which will do computation, and then you can aggregate computation by connecting them to graphs, which are simply webs of plugins passing data to each other to get some kind of result in the level. These are some simple examples of plugins you can do, like primitives, of course. If you're going to do a 3D package, you can do primitives. And you can do filtering and constraints and logic testing, whatever. The quoted intelligence there refers to the fact that you can also use Purple to use Verse by itself to do like VR or some big world, and use add behaviors or intelligence objects. You can use Purple in the background to do that. And then there's a short example there. I have a huge plugin which is 60 lines of C. Actually, I optimized the API after writing these guys. It's more like 48 lines long, I think. And I didn't just remove my line feeds, I really simplified the API. This shows you a bit how the plugins oh, bad pocket to you. Sorry about that. I'll keep my hand somewhere else. Yeah, it's really straightforward. If you have a graph like this, it starts out with a sphere. You have like simple scalar inputs to the sphere plugin, like a color and a radius. And the code in here creates the geometry and passes it out to the other plugins. Maybe a scale, maybe a shear. And then they can pass it forward to like a morph, and it goes on and on. And Purple will track these inputs and recompute as needed. Currently based on simple one input changes that plugin will run again. This might be too simple and have to work on it. The actual Purple engine is a simple standalone program that is also Verse client, like every program Eskil showed, only without the flapping interface. And it runs more like a server on itself. I think I have a slide. Yeah, so it will mirror all the data and it will do its best to hide some of the messy details of using Verse raw by making the data appear in your local memory, so you don't need to do all the network round trips that are usually required by Verse. and it will load the plugins, of course. It has no interface. The plan is to separate out the interface and do it in a separate program. But we'll skip that a bit. Here's a simple graph. I told you. Yeah, this is like the internet. You always have to do internet like a cloud. This is important. This is the verse load, so the server that Eskil ran. So the data. The purple application running somewhere like close to the host. Like you don't put the purple over here because you want low latency here. So preferably locally close to the host. If no interface is running or whatever because the traffic is less there. And yeah, writing plugins can be simple. I'm working on the API to make it true. You have like 4 classes of code you can use in the plugin code to initialize yourself, read your inputs, work with the node data, and then output something to run plugins to active. Wow. Yeah, this is because when I sit in like an audit like this and someone talks about programming, I always go, show me the code, show me the code. So right, here's some code. This is a very simple plugin that simply computes the sum of 2 numbers. It has an int function. This is the only global function in the plugin that is required by the API. Purple will look up this function and call it. The plugin uses the init part of the API that I showed you to describe itself basically and register its compute callback. And this is what Purple calls when it needs the plugin to refresh its output. And simply reads off the inputs using these calls, and then immediately sets the output to sum and tells Purple that I'm done. And that's basically it for a simple plugin. That does the annotation of the compute callback. The only thing I'll mention now is that you have the option to return that you're not done actually, and then Purple will call you again or at a later time without inputs changing, which is useful if you need to do some long computation. Then you have to split it up into segments by yourself, because Purple isn't through multitasking anything. That's responsibilities right now for programmers. And wow, and basically I'm out of time here. So we are 5 minutes, okay, so maybe I should just cut to the chase and show you a very simple demo of Purple actually running. It's more exciting because I have further chances to crash running my code and not OpenOffice. So let's kick it off to the verse server. Here we are. And then what is that? There are the actual Purple engine running. And then I'm going to wait for a while. And then, like all good demos, I'm going to do something I want to explain. Oh, you don't see this. Here we are. No, actually, I was faking using this and talking to Purple, asking to do that. But I did it using the console because I'm correct. And now I'm going to run a very simple renderer on top of this. Here we are. Now I'm very happy that Eskil was before me, so you have seen some beautiful polygons today because this one was several reasons. We'll be able to pan the camera if I have enough button more, but I don't, so we'll see the view from this nice top angle. What I can do now is I can also remember to show you the actual graph that I'm running in Purple right now, which I was very, very good and actually did during Tom's talk. I forgot this way, so it's outrageously beautiful. Here we go. So the graph that Purple is running right now has these 4 plugins. It has the aforementioned cube printed. It has something called VBox, which computes a bounding box. It has a simple warp, which will do a twist along the y-axis of the vertices that flow in here. Now we have an output which makes the data go back to the cursor. So now if I simply ask Purple using another deeply textual command like this, I can set this twist angle, and you'll see immediately the cube gives that twist. And this is of course nothing amazing. Normally, to me it's rather amazing because this is like construction history pipelining on top of verse, which is some pattern native verse into stores polygons. But now we're like listed the level using the plugins. So I can put a bigger angle. And I can also make the cube bigger by talking to the cube plugin. So then I get a bigger cube that is still twisted, because properly reruns the entire graph. And it processes the vectors, and they are also sent back to the server, of course. And if we were slightly better prepared, we would be able to run Eskil's tools showing the same cube, of course, because the data is all time stored on the server. So it's network accessible. And yeah, so now Angela is going to wrap it up. And I guess I'll just fast forward to that. And I hope you've gotten some idea, and if you visit us tomorrow during our developers talk or developer session, I'll be able to talk at length about